Hello again and welcome back to our course on Excel 2019 Advanced. In this section, we're going to look at the use of Solver, and before we start, I just want to point out that it's quite possible that if you look on the Data tab on your ribbon, you won't even see Solver there. Solver is a free add-in and we're going to be using it in this section, so if you are intending to work along with me, you might want to enable it now. If you go into File and then down into Excel Options and go to the Add-ins page, and in the Manage Excel Add-ins, click on Go, and one of the add-ins you should see is the Solver add-in. It is free, so just select it and click on OK. And you should now see that in the Analysis group on the right-hand side, you have Solver. You won't actually need to click on Solver just yet, but we are going to come back to it later on. Now let me tell you a little bit about Solver. In the preceding section, we looked at GoalSeek and I showed you how to vary one variable and let GoalSeek use what is in effect brute force to supply the value that produced a particular answer in the use of a formula. With Solver, you can deal with much more complex situations, and in particular, you can not only vary many more input variables, but you can also put constraints on the solution as well. Now, in order to demonstrate Solver, I'm going to use a fairly practical example. Now, my friend runs a cafe, and that cafe is open 7 days a week, only during the day, and the number of staff that my friend needs to employ needs to be judged so that the peaks and troughs in the business can be catered for. So for instance, the cafe is particularly busy at the weekend and tends to be quieter during the weekdays. My friend has worked out how many members of staff are needed on each day, but he is struggling to work out how many staff to employ overall in order to cover the required number of staff. I'll explain what I mean by that a little more as I start to set up the model that we're going to use to solve this problem. So let's start to build this roster for my friend. Now, first of all, you can see the 7 days of the week there, Sunday to Saturday. And in row 16, I've put the number of staff my friend needs in the cafe. So 11 are needed on a Sunday, 7 on a Monday, 9 on a Tuesday, and so on. Now, these are minimum numbers. We can't go below these numbers on any day of the week. Now, let's talk about some of the constraints on the solution to this problem. One of the constraints is that each member of staff works 5 days a week, and those 5 days need to be consecutive days. One of the reasons for this is that each member of staff must have 2 days a week clear as their weekend break, even if it's on, say, a Monday and a Tuesday, or a Tuesday and a Wednesday, so on and so forth. The 5 days they work are 5 consecutive days. Nobody works overtime and nobody works part-time, so each person does 5 consecutive full days. Now, there is going to be one other constraint that I will come back to in a moment, but that's the basic model. Now, the way that we set about solving this is first to say, okay, given that each person works 5 days, we could have somebody called a Sunday person. And a Sunday person would work Sunday, Monday, Tuesday, Wednesday, and Thursday. And in fact, we could have more than one Sunday person. We could, for instance, have 2 Sunday people. And if we had 2 Sunday people, we'd have 2 people on a Sunday, 2 on a Monday, 2 on a Tuesday, so on and so forth. So if we say that the number of Sunday people is what's in B5, then in terms of the contribution to the staffing of the cafe, the number we put in here is indeed B5. And the same will be true for each of those 5 days of the week. So I will do a fill right. I'll also apply a bit of formatting. I'll just center those to make it easier to read. And with that, you can see what contribution they make to the cafe. I'll do the same for each of the other types of person. So for each of these other types of person, I've taken into account the day of the week that their week starts, their 5 consecutive days, and just to get us started, I've assumed I've got 2 of each, and based on that, I can calculate how many members of staff I will have staffing the cafe on any particular day of the week. So for instance, on a Sunday, the total number of staff is equals sum D5 to D11. And of course that's 10. And if I fill across, at the moment I have 10 people on each day of the week, which is fine on Monday, Tuesday, Wednesday, for example, but not so good on Friday, Saturday and Sunday. Now returning to the iteration approach, I could sit here all day and change the numbers in column B and try to come up with the best solution which would satisfy the requirements that I have at least the number in row 16 on each day of the week. Or I can say to Solver, find out what the numbers in B should be, and the requirement I have is that overall the total number of staff I employ should be as low as possible. Now the total number of staff I'm going to put here in cell B12. So it's equals sum from B5 to B11. And of course, this is the number that I want to be as small as possible. So it's time to try Solver now. Let's go to the Data tab and Solver. And it opens up this nice big Solver parameters dialog. Now the first thing we do is to set our objective, and our objective relates to cell B12. Because ultimately what we're trying to solve is to make B12 as small as possible. Now I have 3 options for my objective. So my objective could be to make it as big as possible, max, as small as possible, min, or to achieve a specific value. Now in this case, I want to achieve the smallest value as possible. So I'm going to leave min selected there. Now in order to do that, which cells am I allowed to change? The cells I'm allowed to change are these cells, B5 to B11. And the idea is that I'm going to change those to make B12 as small as possible. Now there are of course constraints, and let's look at what those constraints are. Let me just delete out because these are old ones. And let's start with a clean slate. So let's add our first constraint by clicking the Add button. So our first constraint is that our numbers in D14 to J14 must be greater than or equal to the numbers in D16 to J16. And click OK. That's our first constraint. Let's add another one. So the next constraint is a very, very important one, and that is the numbers in B5 to B11 must be whole numbers. So the next constraint we're going to add is that the numbers in B5 to B11 must be integers or whole numbers. That's our second constraint, and click OK. Now notice another checkbox here, make unconstrained variables non-negative. Now there aren't going to be any negatives here. We're not going to have negative numbers of staff or negative totals on duty. And there's also a box here, select a solving method. For those of you with a background in mathematics or in many aspects of business administration and management, you may have heard of linear programming, Well, basically, Solver uses linear programming to solve these problems, and it has three options. And these three options will help you try and solve a problem. If it can't solve a problem using what's called the GRG non-linear engine, you have two other options, the Simplex LP and the evolutionary engine. Now, I'm pretty sure it's going to solve it with GRG non-linear without any trouble. So let's give that a go. Click on Solve. So Excel thinks about it for a while and it believes it's come up with a solution, and you can keep its solution, or you may want to have a look at it first. You can restore the original values, and you can also return to the solver parameters dialog, and you can even save this as a scenario if you want to. So for the moment, let's click on OK. And let's examine what we've got here. Well, according to Solver, we don't want any Sunday people. We want one person that starts on a Monday, 3 that start on a Tuesday, 5 that start on a Wednesday, so on and so forth. And the smallest number of people that can satisfy this requirement is a staff of 15 people. Now, I can see the main downside here is that we're going to have far too many staff on a Wednesday, but here's a challenge for you. See if you can come up with a better solution than Solver using exactly the same constraints, and I'm pretty confident that you probably won't. So that is the use of Solver. Exercise 8 is an exercise on the use of Solver. That's in the next section. I will see you there.